Okay. Next, Jared Swenson. Elevation, genetics, and tree mortality. Timing is everything. His program is the Master of Science in Biology, and his faculty advisor is Dr. Amy Whipple.
I love hiking, but Arizona's extreme weather makes it incredibly difficult to prepare for. Luckily, I can quickly and easily adjust to extreme weather by layering clothing and taking extra water, but most organisms can't. Life's ability to survive in extreme conditions fascinates me, especially when it comes to trees. Because unlike animals that can fly, migrate, hibernate, or grow new coats, trees are pretty much stuck. They have to deal with whatever conditions hit them, and not just for a few days, months, or years, but for tens, hundreds, if not thousands of years. Take, for example, southwestern white pine, the tree species I study. If you've hiked anywhere above 8,000 feet in the southwest, you've seen this species. They produce huge cones that provide food for wildlife and are an indicator of ecosystem health. Since they grow on isolated mountaintops, they are vulnerable to climate change. For example, if it is too hot and dry for ponderosa pine here in Flagstaff, they can slowly retreat up the mountain. But southwestern white pine already grow on the mountaintop, so they have nowhere to go. In order to protect this species, we need to understand how genetic diversity contributes to survival under extreme conditions. To do this, our group gathered seeds from southwestern white pine trees across the Southwest and planted them in 3 different gardens at 3 different elevations. A low elevation, hot and dry like Prescott, an intermediate like Flagstaff, and a high elevation, cold and wet like Snowbowl. We record which trees die and which trees survive. We also record when trees start growing in the spring and stop growing in the fall. If trees grow too early, they risk dying from either freezing temperatures or drought. We can then combine these data to look for DNA markers that contribute to mortality. If we can identify trees with the genetic capacity to survive both freezing temperatures and drought, we can better protect this species. So far, of our 22,000 trees, over 25% of them have died. The biggest factors contributing to mortality are the garden that they were planted in, high, intermediate, and low, and the year in which they were planted. As we've seen here in Flagstaff the past few winters, conditions can drastically change from year to year, and this dramatically affects what can survive. Mortality is also related to where the seeds originated from. Seeds taken from trees in more southerly, warmer climates die most when planted at the highest and coldest gardens, telling us there's some interaction between climate and genetics that dictate under what conditions these trees can survive. While it may be tempting to transplant trees in anticipation of climate change, resilient trees must be able to survive the extremes of both current and future climates. With our data, we hope to be able to predict which trees will survive under whatever conditions nature throws at them and help buffer this species against climate change. Thank you.